Okay, so in this video, we're going to look at active transport. This is something that you may have looked at high school. Still, it's very important to make sure we're using the right terminology. So, active transport, in simple terms, is moving molecules. We're just going to say things for the time being, because I'll give you some examples. We're going to move things from where there are very few to where there are lots. So we're in effect going from a lower concentration to a higher concentration. Now, in your exam, you will have certain examples. Now, just one really common one that's used in nerves are sodium ions. So I'm going to use that as my things. So on the right-hand side of the page, we've got a lower concentration of sodium ions, and on the left-hand side, we've got a higher concentration of sodium ions. So in active transport, what we're going to do, we're going to move them across the membrane to the other side. In order to do that and move these sodium ions, we're going to use carrier proteins, so proteins that are actually inside the membrane, and we're going to use ATP. ATP is a molecule, it's a thing. If you had enough of it, you could have a pile of it on your desk. The really important thing with ATP is that it's the molecule that we use to give us the energy to do a particular process. So for example, ATP can be broken down, it can be hydrolyzed to release energy to allow active transport to occur. So as a summary as to what active transport is, it's the movement of molecules, my example was sodium ions, from a lower concentration to a higher concentration using a carrier protein, and in that process it's an active process, so it requires ATP. Now ATP, just a quick overview what ATP is. ATP, like I said before, is an actual molecule, it's a thing, you could have a pile of it. What we do with that ATP is we break it apart, we hydrolyze it, and the energy that comes out allows us to drive particular processes. Now, ATP is made in respiration. It's mainly made in aerobic respiration, that's where we make a lot of it, but it can be made in anaerobic respiration too. So as we hydrolyze ATP, it forms something called ADP and an extra phosphate. And that allows the carrier proteins to get the molecule or the sodium ion and push it through the membrane. It'll change shape, the protein will change shape, and it will push the molecule to the other side of the membrane. Now, just one really quite important thing, there are particular toxins that can stop mitochondria from working. And if mitochondria don't work, then they don't produce ATP, and therefore active transport can stop. So active transport can be stopped by preventing the molecule that gives us the energy. We can stop ATP production, and by doing so we can stop active transport. Another way to stop active transport is to actually stop the way the proteins work. So there are again toxins that can stop the carrier protein from changing shape, and that will also stop process of active transport.